Hi everyone and welcome back to our trigonometric equations lessons. In today's equations we're looking at functions where their angles are different and we're still going to determine the general solution. Now here is our example. We are given a sine of an angle which is equal to the cosine of a completely different angle. Can you see this one is not the same as that one? Now before we start answering equations in trigonometry, we want to first identify what we are working and dealing with. So we are busy with a sine of an angle which must be equal to a cosine of a completely different angle. So our job now becomes this. We want these two functions to be exactly the same two functions. So I can either change the sine to a cosine, or I have to change the cosine to a sine function. Now I always like to work from left to right, and I like to change the right side's function so that it looks like the left side's function. Now how can we change a cosine to a sine function? Now here comes the important part. We use reduction formula. So here we go. Sine of x minus 20 degrees is equal to, and then I change the cosine to a sine and I make use of 90 degrees minus this original angle. Now because that angle has two terms in it, I have to keep it in brackets because this is going to be distributive law, right? Okay, and I close the brackets because this is now the new angle for the sine function. And then sine x minus 20 degrees is equal to the sine function, and then we use distributive law here and we end up with 90 degrees minus 2x minus 30 degrees. Then we solve for this angle inside these brackets and we end up with the sine of x minus 20 degrees equals the sine of 60 degrees, because 90 minus 30 is 60, and we still have the minus 2x. Okay, wonderful. Job done. We've got the same two functions in this equation. Now here comes the next part, and from here on it's quite easy. So we take the sine function and we break it off and we take it as its inverse to the other side. Now it looks like this. X minus 20 degrees is equal to the sine to the power of negative 1, and we use this part as our ratio. So we just write sine and 60 degrees minus 2x. Now, where we previously had, when we take the sine function, for example, and we take it over as its inverse, we usually wrote the ratio down in brackets, right? Now, this part is the ratio, as I said earlier. So luckily for us, where we had to do the calculation on our calculator to find the reference angle, we don't have to do it now, because this sine's inverse and this sine function will just cancel out. There we go. So this angle here is the reference angle. So x minus 20 degrees is equal to 60 degrees minus 2x. Okay, so this original angle, there we go, is equal to this reference angle. And I underline it. There it is. Now our next step is to find out in which quadrants we need to work. So I go to where I have my sine function with its angle, and it's equal to, and look here, this is a positive ratio. Or I could also go to the original question and I can just look at this, because it's the sine of its angle is equal to a positive ratio. So obviously we're working in quadrants where the sine function is positive, which is quadrant 1 and quadrant 2. So here I go. I write down quadrant 1 and then I take this angle and I write it down. X minus 20 degrees is equal to 60 degrees minus 2x plus the 360 degrees times k. And then I just take this minus 2x to the other side, it becomes a plus 2x, and this minus 20 degrees to this side, it becomes a plus 20. So I end up with 3x equals 80 degrees plus 360 degrees times k, and I have to divide all the way through with a 3, so x is equal to 26,67 degrees plus 120 degrees times k. Now the next quadrant is quadrant 2, so I write that down, and in quadrant 2 we work with this critical point minus the reference angle, right? So I take all of this and I write x minus 20 degrees, which is our original angle, is equal to 180 degrees minus this reference angle. Now again, because this is two terms, we have to keep it in brackets, right? And then plus 360 degrees times k. Then we do the distributive law here and we end up with x minus 20 degrees is equal to 180 degrees minus 60 degrees plus 2x plus 360 degrees times k. Then we move this plus 2x to the other side, it becomes a minus 2x. This minus 20 goes to this side, it becomes a plus 20. And we solve the degrees and we solve for the x's and we end up with minus x is equal to 140 degrees plus 360 degrees times k. And then we divide with this minus all the way through and we have x equals minus 140 degrees minus 360 degrees times k. And there we go. So what is very important, when we have trigonometric equations where the functions have different angles, we're going to make use of reduction formula. See you again soon. Bye.